Good morning, my dear student. In previous class, we discussed about introduction, that means definition of power quality and also power quality terminology. Now we discussed about which is the severe faults in power system. So that means sag, swell, interruption. These are the very disturbances in power system. So suppose this is a sag. If there is a 100 volts sinusoidal AC system, so this is a sag. Sag means the decreasing in magnitude. So actual waveform is a 100 volts. If actual waveform is 100 volts, the less than 100 volts is a sag. More than 100 volts is a swell. If there is no input, that is called interruption. So please observe sag waveform and swell waveform and interruption waveform. So this red is a reference quantity. Please see sag system. So the sag is under voltage, the swell is over voltage, the interruption means no voltage. These are the RMS values. So harmonics. So harmonics also a very important in power system problem. Please see the harmonics. The waveform is changed due to harmonics. Exact sinusoidal waveform not appears due to harmonics. If you observe the normal waveform and harmonic waveform, the difference you observe that one. So if the normal waveform is a exact sinusoidal, harmonic content is a distorted waveform, which causes number of losses in a equipment, which causes damage the equipment. Harmonic. So this is a sudden change in voltage or sudden change in current. Also we call this a surge. Observe all the things, which is the normal waveform, which is the sag waveform, which is the swell, which is the interruption, which is a harmonic content waveform, which are the surges. These are the important power quality disturbances. This causes the power quality is decreases. So this is a transients. This is a transient sudden changes in voltage levels, because any thunders or lightning strokes in appeared in feeder causes distorted in waveform. So next one is a what is meant by power factor. So the power factor is a important phenomena, everyone know. So what is a power factor? So the angle between the voltage and current. The angle between voltage and current. Phi is the angle difference between voltage and current. This appears only in AC quantities. In DC quantities, there is no angle difference between voltage and current. Already we know. So inductive circuits mean the current is lagging. Capacitive circuit means the current is leading. So if you observe what is a power factor, exact definition is equal to actual power by apparent power, or power factor is equal to cos theta. So this is a actual power, this is a reactive power, this is a apparent power. So this is a power triangle. In power triangle, so in power triangle cos theta is equal to the actual power by apparent power. So power factor is nothing but cos phi or cos theta. Angle difference between theta is the angle difference between voltage and current. So what is a important one is a power quality problem evaluation. How to evaluate the power quality problem is a very important phenomenon. So how to evaluate means there are number of steps to evaluate. So the first step is identify problem category. So whether this is sag or swell or interruption or surge or transient, you must observe that one. So problem characterization, how much it time takes, that's also important. Identify range of solution, how much voltage it raises, how much voltage it decreases, how much time there is no voltage or no current, that means interruption. You must identify that one. So evaluate the solution, optimum solution. So if you identify problem means voltage regulation or unbalance, voltage sags or interruption, flickers, transients, harmonic distortion. You must observe first which problem arises in a power system. Next one is a problem characterization. So measurement and data collection. So that is the causes. What are the causes that appears? What are the characteristics that have? So which equipment impacts? So the third one is identify range of solution. That means that is lies in utility transmission system, utility distribution system, end use consumer interface, or end use customer system, equipment design or specification, evaluate solution, modeling or analysis procedure, evaluate the technical alternatives, finally optimum the solutions, evaluate economic of possible solution. So classification of power quality issues. So the classification, so the power quality classification means in terms of power frequency disturbances, that nothing but harmonics, in terms of power magnetic interferences, in terms of power system transients, electrostatic discharge, power system harmonics, power factor, grounding and bonding. So these are the severe problems in power system. So what are the causes and effects we see? So the first problem is voltage sag. Voltage sag. Already I told that the sag means the decreasing of voltage by reference voltage. For reference voltage, if the reference voltage is 100 voltage, the less than 100 voltage is a sag, voltage sag. So what are the causes of voltage sag means? Faults in the transmission or distribution network. The faults may be a line to line or line to ground or triple line, either symmetrical or unsymmetrical. So faults in consumer installation, connection of heavy loads and startup of large motors. So what are the effects of voltage sags? Tripping of contractors and electromechanical relays, disconnection and loss of efficiency in electric rotating machines, etc. Voltage spikes. Voltage spikes means lightning, switching of lines or power factor correction, capacitor, disconnection of heavy loads. Destruction of component and of insulation materials, data processing, errors or data loss, electromagnetic interference, etc. So voltage swells for causes are start and stop of heavy loads, poorly dimensioned power sources, poorly regulated transformers. So flickering of lighting and screens, damage or stoppage or damage of sensitive equipment, etc. are the effects for voltage cells. So another one important problem is voltage fluctuation. The voltage fluctuation causes are arc furnaces, frequent start and stop of electric motors, for instance elevators, oscillating loads. Most consequences are common to under voltages, flickering of lightning and screens, etc. Voltage unbalance, large signal phase loads, induction furnaces, traction loads, incorrect distribution of loads by the three phases of the system. The most affected loads are three-phase induction machines, increase in the losses, etc. Harmonic distortion, switched mode power supply, fluorescent lighting, three-phase rectifier. So the effects of harmonic distortions are conductor overheating, neutral overloads, increased probability of occurrence of resonance, nuisance, tripping of equipments.